Welcome everyone to this week's latest hit Bitcoin Tech. So this week we'll try to build upon last week where we had an introduction about CoinJoin and the different types of protocols used in CoinJoin. We primarily try to understand about zero link CoinJoins, and there are two implementations of zero link CoinJoins. One is WabiSabi by the Wasabi team, and the other one is Whirlpool by the Samurai team. So these are the basic or two important CoinJoin protocols that have been implemented based out of Zero Link. Um, Today we will, to begin with, we'll just have a very basic understanding about the differences between Whirlpool and Wabi-Sabi. Although I won't be able to go into the technical details of the Wabi-Sabi protocol because it's a lot more involved with a lot more involved than blinded signature. It involves range proofs, zero knowledge proofs in order to realize some of its features. Uh, Rather, what we'll do is that we'll try to understand what Whirlpool does and what Wabi Sabi does differently, and then try to explore the um, Ashigaru wallet interface. So we'll try to explore explore the basics of Wabi Sabi and Whirlpool, and then we'll try to get into the we'll try to get into the details of how to or we'll try to learn about the interface of Ashigaru and how to set up an Ashigaru terminal in testnet 4. Although I thought of showing a coin join round itself, but there seems to be some issue with the testnet 4 coordinator of uh, Ashigaru. Yeah. So we'll try to understand a little bit more about blinded signatures, and then see how Wabi Sabi is a little bit different when compared to blinded signature setup. And then and then we'll move on to the Ashigaru interface. So this is so as we saw yesterday, Whirlpool is just a is another implementation of zero link coin joins where you take in inputs where you take in inputs and inputs of different where you enter into a pool with let's say a pool of fixed you take a fixed amount size, and then you put in your inputs into that pool, and when it comes out you'll get equal valued outputs. So that is the basis of zero link coin join, and the problem comes with how to handle the change that you get out of it. So that's where most of the technical differences between Samurai and Wasabi lies. So in Samurai, it uses blended signatures in order to coordinate the interface between the user and the coordinator. So here, what happens is that the user first, to begin with, the user have to establish proof of input ownership. So what he will do is that he will typically construct a message which includes the TX ID of the UTXO, the vout number of the UTXO, and the amount that he wants to send, and also some more details about the round. For example, in Whirlpool's case, he will also send information about which pool he is interested in, and also which round he is in, whether it's the first round, second round, fifth round, etc. So these kinds of details he will construct as a message and sign it, and then send it along with this public key to the coordinator. Now, what the coordinator will do is that he will verify whether he'll verify first. He'll verify the signature that the user has user sent, so that the coordinator can be certain that the user controls the user means whoever made the connection with him controls the UTXO. So once he is satisfied, he will let ask the user to proceed further. Here the user will first he will do is that he will um, blind the output. This step is done because the user now sends an output address in which he wants to receive the coin join transaction. So what the user will do is that he has to like dissociate his connection identity. In the case of Tor, his Tor identity, but in the case of ClearNet, it's his IP address. The user wants to disassociate this information from the uh, from his output. So in this step, he'll blind his output and send it across. The idea behind a blinded signature is that they are reversible for the user but not for the coordinator. So he will send the output address in a blinded fashion. Now the coordinator doesn't see the actual output address, but some other hex value. All that the coordinator does is signs the blinded address and then sends it back to the user. Now, because the user has the keys to unblind the signature, he will unblind it. What this unblinding means is that whatever signature that the that the coordinator sent to the user will be valid for the modified address and also for the actual output address that the user wants to receive. Now, what he will do is that he'll take out the blinded or modified output address and put his actual output address in which he wants to receive the coin join UTXOs. So here, what happens is that once he unblinds and reconstructs it with his desired output address, he will reset his connection identity. The user will disconnect from the coordinator, and he will connect back with a renewed identity, a renewed Tor identity. And then what he will do is that he will present the unblinded signature and the output address in which he wants this address and the amount. So what happens here is that now in the previous identity, uh, um, while using the previous identity, the user had his input registered and he sent an output address. So till this step, the coordinator, if it was not for this blinding signature process, the coordinator could link the input and the output address of the user. But with the blinding signature, the coordinator can no more link the input that the user registered with the output that is sent finally here. So this is how a coordinator uh, this is how a coordinator is or doesn't have access or visibility over the input and output of the user. So this is how the unblinding the blinded signature helps one to not deterministically helps on to prevent the coordinator from deterministically linking the input and output. So now even the coordinator doesn't have access or doesn't have visibility over the inputs and outputs that are being used. So, so that's about the blended signature process. If we move on to the WabiSabi 2.0 protocol, here it does the blinding a little differently. So in the registration process, what happens is that the communication begins with the coordinator. Typically, the coordinator publishes the round parameters, that is details about um, like ground is open for registration and which endpoints to connect to and things like that. Once the user receives it, what the user does is that through he creates zero value credentials. So using a process, the user creates credentials that he can share to the coordinator, and the coordinator can identify the user with. Instead of just using the connections identity, here in this protocol, there is a specific identity generation process or credential generation process that happens, and the user sends those across to the coordinator. So once the coordinator does verification of these zero value credentials, then he generates a message on authentication code and then sends it across to the user. So basically, what this two-way communication does is that it gives the it gives the user it gives the user a sort of voucher or a set of identity that the user can use to tell the coordinator that it is indeed the user that is communicating with him and not somebody else that has intervened or supplanted him in between. So that's what this whole message authentication code process does. So once the user has vouchers that represent his identity, then he goes on to generate zero knowledge proofs about the UTXOs or inputs that he want to put into the mixing process. Now, because of this zero knowledge proof, Bob, it is possible inside Wasabi to bring in not just like there is no concept of fixed sized pools in WabiSabi because of this zero knowledge proofs. You can like the round can consist of inputs of varied sizes and outputs of varied sizes, and it is not possible for you to link the input with output even in the case of even if you have varied outputs. Whereas in Whirlpool's case, uh, you will enter into you will enter into pools of fixed sizes, zero point zero 0.01 BTC, 0.025 BTC, things like that. And then your privacy comes from being one among the many. But in Wasabi 2.0, even though you go into a round with the distinct inputs, and you also expect distinct outputs from the round, there is no way to deterministically link an input with the output. That's because it starts implementing zero knowledge proofs along this process. I don't, at least I don't have like enough knowledge about the entire process in detail, so that I am not in like I won't be able to explain to you in so much detail about how the zero knowledge proof process mm, zero knowledge proof process is implemented by Wasabi, and how it helps you realize helps you realize these things. So that's um, I'll stop here. If you have any questions about these two ideas, I'll wait and then we can proceed to the wallet part. Yeah. Okay. So just a minute. I'm trying to uh, share the phone because Ashigaru is only available on mobile wallet. So let me try. Is my screen visible?
Yes, yes.
Okay. So basically, so this is the interface of Ashigaru wallet. So let me get into it. So yeah, is the wallet's interface visible? Yeah. Okay. So I have given the link to the wallet in the announcement page. You won't be able to find this wallet in any of the Play Store, iOS stores, or even F-Droid. You won't be able to find it because they have restricted the distribution of it only to their official GitHub repo hosted only via Tor. So you can reach them only via Tor. So please be careful if you are trying to use Ashigaru. Don't download it from any other sources. Just go to their GitHub mirror or hosted over Tor and download it from there. So after you install the app, you will basically be asked whether you want to restore any wallet that you have or create a new wallet. The usual stuff. You can like play with the wallet in testnet also. It will show you an option to choose the network, so you can do that. Once you get into the wallet, this is typically the interface that you will see. So here you will have a list of transactions that is there in your wallet, and you can. So these are the transactions. If you want to have a view at the UTXOs that you have, you can press this button over here over the right, and you can see the unspent transactions that you have in your wallet. So this is what is called as coin control. You can see some details about each of these UTXOs. You can add notes with respect to these UTXOs. Let's say you want to enter it here as um, something you want to name this coin. Let's say don't spend, and you can add a note to it. So these are some of the features, basic overview of features. And here, the cone in the top right gives you details about the network. You like now it is connected to a node. So this is the no. You have to like have your own node for in order to connect to this wallet. But for testnet, there are a few nodes that are being run by the Ashigaru team with which you can connect, and then you can play around. Once you are confident enough, you can switch from a testnet node to your own node. So you can have this also gives the pairing credentials of the node to which you are connected. So you can have those details. And it's always over tar, so the tar routing will be on by default. And so that's about the network to which it's connected to. So if you click the plus symbol, you can see a few options. One is to send a transaction, the other is to receive a transaction. If you press receive, it will show you a address, and you can share this however way you want. So that's about sharing. So next comes the so if you look at the top left icon, so that is that gives you more details about the wallet itself. So it has a lot of tools. You can have it also have under the collaborate section. If you go into you can first claim your pay name, and then you work from there. That's the collaborate section. What is pay name and those things, I think we'll have to do a separate session on that. So, in short, paynims are nothing but uh, like are a system through which you don't have to paste or provide a single static address in public. For example, you want to put up a donation link. Um, Without paynims, the only other way is to put up a static address, and everyone can look into what's happening in and around that address. So in order to avoid that, paynim is a method by which you can avoid it. Of course, there is also silent payments. It's another method to avoid sticking to static addresses. These are the two different privacy methods that are currently available to receive payments in a sort of a privacy preserving way. So that's about paynims. Then you have tools. So if you go into tools section, you will have a lot of advanced tools. um, you can use this sweep private key function to basically, if let's say if you have a paper wallet somewhere, one private key containing a few coins, you can use this sweep private key tool to bring those coins into this wallet. Then you can create you can sign a transaction. For example, cold card sends you a PSBT, that is which whose private key is associated with this wallet. You can use a sign transaction to do it. Then you can of course broadcast transactions. When you have a signed transaction, any signed transaction, which doesn't even have to be related to this wallet, if it is signed, this wallet can broadcast it via the node connected to it. Then, of course, it can sign a message, verify a message. It can calculate addresses for you. Uh, so you can like change the index and get at different addresses. Uh, so there is basically two different sections: external and internal. Internal is used for change. So as you keep changing the index, you will keep getting different addresses. So that's about the address wallet address calculator. Then you have Payname address or calculator. Then you can authenticate using Payname. So these are two other tools associated with Paynames. So this is about the two pairing. And if you go into settings, you'll have a bunch of settings. You can like basically change the apps icon into anything. It will not look conspicuous. Then you can add a pin and you can erase this wallet and add new wallets. If you go into wallets, it will show you the mnemonics of the wallet, passphrase. You can view the expubs. So there are a bunch of expubs associated. We'll see these things as we go along. Uh, then wallet info logs. So these are the things. And for backup, because you are adding labels and stuff like that, this wallet itself will generate a backup. And if you want to like keep using Ashigaru, and if you want to keep using Ashigaru and you want a backup of it, then it's best to theoretically take out these backups from the location mentioned here and save it elsewhere, so that even if you lose the mobile or the app gets deleted, you can get all the information with a combination of your seed words and this file. You can also encrypt this wallet backup. Those are setups that are given here. So if you go into about, so it'll give you a bunch of details about it. As you can see, the website is only available over tar, and you can copy this URL and look into the details. Then I think, okay, here, um, if you go to wallet, you external public key, so wallet account activity. So yeah, these are so as you can see, this is a little bit, this is a complex wallet, not a simple wallet where only one derivation path or one single descriptor is used. It uses multiple descriptors for different functions. So if you can see, the most basic type is the deposit wallet descriptor, and it has this derivation path of M4410. So so this will be the starting or basic thing. Then you have your BIP49 SegWit compatible deposit address. Then you also have your native SegWit deposit address. Here comes the like the derivation path that is different or unique to this wallet, which is premix. So as we saw last time, um, Samurai or this Ashigaru uses a premix stage, where whatever UTXO that you have is collected and shared and then getting into a pool. So if the pool is 0.001 pool, then you have to collect a bunch of and bring it bring them equal to 0.001 UTXOs. So that and premix derivation path. And after the mixing, the post mix, or after you get and come out of a coin join round, the coins or UTXOs are stored at a different derivation path. So as you can see, because the wallet uses a different derivation path for each of these functions, it is able to isolate mixed coins from non-mixed coins, and it is also able to prevent you from accidentally mixing your mixed and unmixed coins. And also it also has a separate separate derivation path to handle uh, changes that are toxic or that can lead to unmixing. So that is called as bad bank. So it is held in this separate derivation path. And there are other collaborative tools like Ricochet. We'll have to do a separate session on how to use these tools like Ricochet and all to enhance your privacy. So for each of these, it has a derivation path. So this is about the wallet's information. So now, if you see, if you get into the top rightmost icon, you can see a spinner kind of thing. So if you press that, this will take you to the post mix section. So this section is specifically dedicated to coins that you have coin joined or mixed, and it will be stored here. uh, Structurally or functionally, there is no way for you to mix what is here in this section and what is here in the general section. So these are two different parts of your wallet itself. And when you spend, you can only either spend from the coin joint or whirlpool section, or from the regular section of your wallet. uh, so these are the two parts. This is like a brief overview or walkthrough of the wallet. Otherwise, then we'll look into the Ashigaru terminal, which is another tool that is required to start or get into a coin join round. Yeah, yeah, I'll do that. I'll do that. Um, if there are no more questions, then we can move to we'll move to the we'll move to the site terminal. Um, so is the terminal visible? Okay. So there is another application called as the Ashigaru terminal. You can find the link to download it in the same onion link that I have pasted there. So what is an Ashigaru terminal is that um, because when you get into a coin join and you want to keep doing the coin join, you need a live or always on device in the background that can keep communicating with the coordinator and keep creating the new transaction, new keep putting your UTXOs into the coin join rounds. So you need a you need a background process that can keep doing this. So Ashigaru terminal is nothing but a background process that will keep doing this. So when you run this application, it is a application, and when you run this application, you'll I'll try to open it back. Um, okay. So so when you start the terminal, it'll open and it'll automatically connect to tar and it'll also connect to mainnet. Means it'll connect to a node that is in the background. Of course, you can get into the server part and then edit the details, and you can connect to your own server so that you can do. So once you change the details, you can test it and it will confirm. So now for our purpose, we'll go into testnet. So this we'll have to restart the terminal in testnet 4. This is something similar to how you do it in your Sparrow wallet. So when you restart it, it will come back in testnet 4. It will come back and connect in testnet 4. So as you can see, now it's back in testnet 4. You can see the details. Testnet 4 is there, block height is there. So now it's connected to testnet 4. So the next thing that you want to do when this is up is that you want to get into wallets. Uh, here, um, you have to. There are two options for you. One is that you can spin up a separate hot wallet that is completely different from your cold wallet in this terminal, and put in BTC amounts or UTXOs that you just want to mix, and after that you can transfer the UTXOs from this wallet back to your cold wallet. You can do that, or I although I wouldn't suggest it, you can also import your or restore your existing wallet into this Ashigaru terminal by entering the seed words and the phosphorus. So I have like imported the testnet wallet that I showed you in my Ashigaru mobile application. So that is there. I have to enter my passphrase. So it has all the features, BIP39 word list, passphrase, and wallet password also. So you can use whichever you want. So once you you have the wallet open, so it will show you four different sections. One is a deposit section, the premix section, postmix section, and bad bank section. So now, if you want to start a coin join round, you have to like get into the deposit section. So the deposit, as I showed you in the mobile application, it's just a derivation path in your HD wallet, and this is where the first, like this is like the outermost layer of your wallet of your Ashigaru or Samurai wallet construction. So here you have transactions. So if you go here, you can see all the transactions that is associated with this wallet. If you refresh it, it will connect back to the node and then get the transaction details. So that's there. And you have addresses. You have, if you go into UTXOs, it will list all the UTXOs that are associated with the wallet. So this is here. So now, to begin a coin join round, you have to go into your UTXOs, and if you press space, it will select all the UTXOs that you want to coin join. And once you select these inputs and go into mix, so it will open the first section. So what it is doing here is that it is trying to fetch a pool into which your coin join can get into. Currently, there is some issue um, with Ashigaru's testnet 4, but the mainnet is working. Testnet 4 is not able to fetch a pool. So once you fetch a pool, it will show you the details. So if let's say 0.012 BTC to get into a zero point zero 0.01 pool, it will show me the amount to Whirlpool, which will be zero point 0.1, and it will show me the change, zero point zero 0.02, and what is the fees that is involved, and what is the UTXO that will be created in this step. So once it does that, it will get into this section called as premix. So once this transaction is done, if you go into premix, you can see the details of the transaction that you had premixed. So once the premix is done, then the address will move to the um, mixing part. And once the mixing is done, you will receive the transactions in the post mix section. So this is where your final transactions will reside. And if it is the same wallet that is there also in your phone, um, then you can see the post mix. You can see these UTXOs in the post mix section also. And in order to spend, of course, there is no way you can spend from this terminal. You have to import the seed words into your Ashigaru mobile wallet, and only from there you can spend. So this is just to start and keep performing a coin join transactions. So you can see as this is where the coins move from a deposit, from the deposit section to the premix section to the postmix section, and whatever change that is generated in the premix section, which is called as toxic change or bad bank, will be put into this derivation path, and you can see all your changes here in this derivation path. So once you get into all these things, finally you will have your post mix, and you can spend from your post mix. And because until you remove an UTXO from the mixing, it will keep on mixing. So the fees is the transaction the fees is only one anticiple fee. You can see here, this is a one time fee that you pay in order to get into the pool. And once you pay this fee, and as long as you don't disturb it, your UTXO will be used for mixing in the upcoming rounds also. It doesn't stop just with one round. It keeps happening. The only requirement is that you have to keep the terminal running. So it is best to put this or have this terminal on the same machine as your node is, so that you can have this continuously mixing. um, so yeah, that's all I have for today's session. I thought of like showing a full mixing around, but unfortunately, this terminal is there is some issue with the testnet part, and probably I hope it will be settled soon. There are some discussions going on in the GitHub repo, and they are trying to fix it. But the mainnet, there is no issue, and it's working good. You can. I would suggest you to try testnet. You get yourself familiar with the interface, and then start doing your coin joins in the mainnet. For that also, I would suggest to you to start small, and then probably get into a um, full-fledged mixing of your whole coins. There is also a site that shows the current balances. Is that? I think so. No. Okay, I'll try to find that site and post it. That basically shows how much BTCs are currently there in different pools. There are currently two pools. One is point 0.025 BTC, and another one is point 0.025 BTC. So a quarter BTC and 0.025 BTC. So these are the two different pools currently available. You can like mm, check them out and see for yourself. So it's easy. Like you don't have to run a node to try Ashigaru on your mobile and your terminal in testnet. But if you are going into mainnet and start coin joining your transaction, I would encourage you to run your own node. The details as to how to run your own node um, is available in the same Tar website of Ashigaru. You can like find the instructions there. And also, I think Umbrel also has um, the image of Dojo. Dojo is nothing but the node implementation by the Samurai team for their wallets. The Dojo, I think Dojo is also available in Umbrel as an app. You can install it and connect your Ashigaru to your own Dojo. So yeah, if there are any questions, I can take it up.
Hi Bala, can you just approximate what is the fees in all these transactions? If you can just
Um,
summarize.
the typical fees is about, I think, 0.25% of your UTXO's value. Let me just get you the exact fees. So 5% is the coordinator fees for the 0.25 BTC pool, and 5% is for 0.25 BTC pool. So so whatever your total amount that you put in, 5% of it goes into the fees.
Okay, okay. And there is one more means what is the difference between if, for example, we have some BTC and we just put it in, we swap it with the liquid,
Yeah.
and then we take out again, we swap it back to the original BTC and take it out. So how that is different from this, or both
Uh,
are same?
No, that is completely different because you are that is called as a peg in and peg out. So you are like pegging your BTC into the liquid network, and you are pegging out from the liquid network. So given the current transaction fees, I would say pegging in and pegging out into a liquid network would be cheaper because it is at the max two transactions, and fees are 1 cent per VByte. So that will be cheaper right now because you don't have to pay 5% coordinator fee, and you don't have to set up these things, the terminal and dojo and all those things. So yeah, in that sense, that will be cheaper. But the trade-off is you are uh, trusting a liquid network you are trusting the pegging in and pegging out process. Hopefully, right now there is nothing to fear. But yeah, that's where the trust is. When the fees are higher, um, uh, getting into a coin join will be far more cheaper, and also pegging in and pegging out. You will have to like if you are a high value target, there are means by which this pegging in and pegging out can be de-anonymized via timing analysis and stuff like that. Whereas in Whirlpool, those kinds of de-anonymization is not possible, and you can have a little bit of control over when you enter and when you exit in the case of Whirlpool, because if one round is sufficient for you, you can just uh, given the liquidity, there is sufficient liquidity to quickly get into one round coin join. You can basically make one premix transaction, get into the pool, and once one round is done, you can exit and start using your UTXO. But in the case of liquid, I'm not sure about how much time you have to wait in order to peg out. But yeah, that is not under your control.
Okay, thanks, Bala.
Yeah, yeah. So if there are no further questions, um, I think like we are done for the day.